In this video, we'll be talking about MTH106, or you call it MTH106, also known as what? MATH106. So the topic is integration, and these are the subtopics. So this is the part B. So if you are watching this video for the first time, kindly go to the comment section to request for the part A of this video. In the part A, I've explained integration as inverse of differentiation. I also explained indefinite and definite integral, talking about the properties of integration. So in this particular video now, I'll be talking about the third thing to learn under the subtopic, which is method of integration. So the methods we're going to be looking at is just the three methods. The methods are more than three, but in this video we'll be talking about just these three methods, whereby the first one is integration of rational algebraic fraction method. Again, integration of rational algebraic fraction method. The other one is integration by substitution, that is change of variable method. And the third one is integration by parts. Now, let's start with the first one, the first method. First method is integration of rational algebraic fraction method. So the case one, it has two cases. This is the case one. Now let's solve this case one. Whenever you're asked to integrate something like this, what are you going to do? Then the thing you're going to do is you're going to divide. You will divide this fraction. Probably the best way to divide is to use a long division method. So something like this. Something like this. So by saying the numerator will be here, that is 7. Instead of writing 7 first, I would advise you to change this question like this by starting with what? 2x squared minus x minus 7. Then this one will be x minus 2. Now what did I do? I only rearrange by allowing these 2x to come first, this come next, and this come last. Then this minus is going to be here. It's here. So what did I do? I divide through by minus. Then I got this. The same thing for this one too as well. I allow this x to come first, then this 2 follows, and I divide through by minus. So I have this. It's still the same thing. You only rearrange the question. Now let's divide. So using a long division method to divide, then you're saying how many x can we see in this? Can we see in 2x squared? That is what? 2x. So 2x times x, that is 2x squared. 2x times minus 2, that is minus 4x. So what do we do next? Then we are going to what? We are going to subtract. So let me minus. If I subtract 2x squared minus 2x squared, that's 0. That one has gone. Minus x minus 4x, that is what? That will be plus 3x minus 7. Then you have it here like this. Again, you say how many x can we see in 3x? That is what? Plus 3. So after that, plus 3 times x, and that is what? 3x. Then plus 3 times minus 2, that is what? Minus 6. So let's subtract again. I have to subtract 3x minus 3x, that is what? 0. Then minus 7 minus 6. Minus 7 minus 6. That's going to be what? Minus 1. Minus 1. So after the division, we got 2x plus 3 as our answer, and the remainder is what? Minus 1. So we can now rewrite this thing properly. So the question is now going to be integral of this, which is going to be 2x plus 3, then minus 1 over x minus 2. Even if we want to rearrange this, let's say we want to reverse this thing back based on what they give us. So that's going to be 2. If this 2 comes here, that will be minus 2 plus x. So if you divide through by minus, so you still get 2 minus x. You can do it anyhow, but the best thing to do is that you should leave this thing in form of the question they give to you. I only rearrange this question based on to make our division easier. That was why I rearranged the question. But now let me reverse it back. So instead of writing x minus 2, then let me leave it as 2 minus x. So dx. This thing now look kind of easier for us to integrate now. So integrating this now, like I said in my first video in part A, I said it's going to be dx equals to, if you integrate 2x, this on the part A video, I said this 2x, it will work as if it's a power rule. For those that have watched part A, you understand what I'm saying. So it's going to be in form of a power rule, and for a power rule, the integration is going to be 2x 2 over 2. How? By saying 1 here, this thing has the power of 1, so 1 plus 1, that's 2 over 2, plus this 3. If you integrate 3 with respect to x, that will be 3x, based on what? Constant rule. For those that watch part A video, you understand on this thing. So that is 3x minus now look at this, 1 over 2 minus x. 1 over 2 minus x, that is the word logarithm rule. For those that watch part A, again, logarithm rule, and I thought logarithm is going to be what? Ln 2 minus x, like that. So this is now going to be minus ln 2 minus x dx. 2 minus x plus c. 2 minus x plus c. 2 minus x plus c. So after writing this plus c now, then what I'm going to do next, you can see that these two can eliminate these two. So our final answer dx will be equals to, if these two eliminate these two, that will be equals to x squared plus 3x minus ln 2 minus x plus c. So that will be our answer. Yeah, that'll be our answer for this particular case 1. Before we move to case 2, so try this, pause this video and quickly give a trial to this question. So this is the case 2. Now, instead of we to use long division method, then you're going to divide, then you're going to use partial fraction. We will solve it into partial fraction then before we integrate. So how do we go about that? Okay, now let's resolve into partial fraction. Firstly, let's look at this denominator. Let's factorize this denominator. If you factorize it, that will be 2x squared minus 3x minus 2. If you factorize this guy, that's going to be 2x squared. That will be, if you multiply these two together, then you try to look for what is common, like which two number can you multiply together and sum it up, that will give you this minus 3x. So that will be minus 4x plus x. So minus 4x plus x minus 2. So having this, yeah, if you do this now, it's going to give you minus 3x. So finally, we can now say, okay, 2x is common here, open bracket, then x minus 2, then plus 1 bracket x minus 2. Yeah. After having that, then we can now have it as 2x plus 1 and also x minus 2. So what I will do now next is that I will just say 7x minus 4 is equals to 7x minus 4 equals to a over 2x plus 1 plus b over x minus 2. So after saying that, then I will now say, though I can actually put this thing here, this denominator here, by saying 2x squared minus 3x minus 2. So from there, I will now say 7x minus 4 is equals to a in bracket x minus 2 plus b in bracket 2x plus 1. So after that, what would I do next? I will say 7x minus 4 equals to, I can actually expand this. If I do not expand it, I can just substitute the value of x there away by saying a in bracket x minus 2 plus b bracket 2x plus 1. Then what would I do next? From here, x is equals x minus 2. I will equate it to equals to 0. So if I equate it to equals to 0, then that will be equals to 2, like that. So when x equals to 2, I'll put it as 7 in bracket 2 minus 4 equals to A in bracket 2 minus 2 plus B in bracket 2, 2 plus 1. So what would I do next? This is what? This is 14, and this is 10. Yeah, 10, because 14 minus 4 is 10 equals to 0 plus this is what? 5b. And from here, b equals to 10 over 5, and then b equals to 2. Now let's get for a. So getting for a now is not going to be when x equals to minus 1 over 2, because from here now we can actually say 2x plus 1 equals to 0, and then if you equate equals to 0, then our x is going to be minus 1 over 2. So we're going to insert minus 1 over 2 in this same expression as well. So that will now be 7 in bracket minus 1 over 2 minus 4 equals to a in bracket minus 1 over 2 minus 2. So for me, if I should put minus 1 over 2 here, I will still get 0. I will get 0 for this b. So I don't need to put it there. Let me just add plus 0 here. Let me add plus 0 to this place. So resolving this, so here will now be minus 15 over 2 if you resolve this, equals to, and here will be minus 5e over 2. So if you cross multiply and trying to find a, then you are going to get minus 30 equals to minus 10e. And from here, a will be equals to minus 30 over what? Minus 10, and that is 3. So now a is 3 and then b is 2. So now, since we have gotten our a should be 3 and our b is 2, so our partial fraction is now for the a, that's 3 all over. Then what is the denominator we have for the a? And that is what? 2x plus 1. So 2x plus 1. And then for the b, our b is 2. So 2 over, and what do we have? That will be x minus 2. X minus 2. X minus 2. That was all we have for the denominator. So now you can now integrate. So let's integrate this one by one by saying integral of 3 over 2x plus 1 plus the integral of 2 over x minus 2. So now if I should integrate this now, what is it going to give me? It's going to give me something like this. You're going to use that logarithm rule to integrate this now. So to give me 3 times 1 over 2x plus 1, and then for this one too, it will give me something like 2 times 1 over x minus 2. So finally, remember that 1 over 2x plus 1, that will give us ln 2x plus 1 like that, multiply by 3. Then we have it like that. And also for the 2 times 1 over x minus 2, so that's going to be 2 times ln x minus 2. So finally our answer is going to be 3 ln 2x plus 1, so plus this one too, 2 ln x minus 2 plus c. So that will be the answer after solving that particular question. Here is another method of integration, which is integration by substitution, that is change of variable method. So the example we have here is just 2. Now let's solve the first one. So the first one we have here is that integral over 8x in bracket 4x squared minus 3 close the bracket is power 5 dx. Now what are we going to do? To resolve this is that we're going to say, okay, the integral of 8x, we are going to allow this 4x squared minus 3 to represent u. So that will be u raised power 5 dx. Now after having this, imagine that, look at this now. Based on what I've been explaining so far from the part A and this one too, we have x here, we have v, and we have dx here. It's not balanced. So whenever we have x here, x supposed to be here, then dx should be here. If you have u here, it's supposed to be here, then we have the u here. then what are you going to do? Remember I said you should let 4u squared minus 3 represent u, like that. So if you do that, then find du dx. Sorry, 4x x is 4x squared minus 3 equals to u. So now what I'm going to do, find du dx. If you find du dx in this place, you're going to get it as 8x. Now if you have it as 8x, then make the x the subject of formula from this, and that will be if you cross multiply, then you have your du. So your dx will be equals to 1 over 8x du. 1 over 8x du. By the time you do the cross multiplication, I'm making your dx the subject of formula. So we are going to have it as 1 over 8x du. So after having that, then replace your dx with 1 over 8x du. So if you replace your dx with 1 over 8x du, that will be 8x raised power u5 multiplied by 1 over 8x du. From here now, 8x can eliminate 8x. So what are we left with? We are left with integral of u5 du. Now everything is balanced. So now we can now integrate. So u5 is part of which rule? It is a power rule from our part A video. So if you now integrate it now, so our answer is now going to be u6 over what? Over 6. That's it. u6 over 6 plus c, because it is an indefinite integral. u6 over 6 plus c. Then what is the value of u? So u is 4x squared minus 3. So let's replace it back. So u is 4x squared minus 3 raised to power 6 all over 6 plus c. So that's the answer to this. Meaning that if you integrate this question A, you're going to get this particular answer. Now let's move to B. Now let's solve the B. This B, it has exponential, but it's going to solve it. How are you going to resolve it? See the same step with this A. That will be integral of exponential. You allow this 5x plus 2, represent it as u. So then put your dx. Like I said earlier, 5x plus 2 will represent it as u. So what do you want to, so now what will you do next? You will find du dx. So du over dx, and that will be equals to what? From here that will be equals to 5. So after doing that, then make dx is rate of formula. If you make it, your dx will be equals to 1 over 5 du. So after that, you can now replace your dx by, you can replace this particular dx with what? 1 over 5 du. So that will now be integral of eu then times 1 over 5 du. So after having this, what are you going to do? You can now integrate. If you want to integrate, then this 1 over 5 is just a constant or a number. So you can extract it out from this by saying 1 over 5 integral of eu du. Yeah. So if you want to solve this now what is the answer going to be? If you integrate eu, what are you going to get? If you integrate eu, what are you going to get? So integrating this exponential u, you see the same thing as what? Exponential u. So therefore our answer is going to be 1 over 5 exponential u plus c. And then what is u? U is 5x plus 2. So finally you have it as 1 over 5 e 5x plus 2, then everything plus c. So that's the answer I need to have. So this is the third method of integration, whereby it is integration by parts. We're looking at an example in this. This first example is not actually for integration by parts, but I just included it for me to explain what sine, cos, and some sines and cos trigonometric aspects. So there's one thing you should take note, that if you have this symbol, which is this is sine, this is cos, this is minus sine, this is minus cos. So if you are asked to, from the principle of differentiation, if you differentiate sine something, you're going to get cos of that thing. For an instance, if you say sine theta, if you differentiate sine theta, you're going to get cos theta. If you differentiate cos theta, you get minus sine theta. If you differentiate minus sine theta, you get minus cos theta. And if you differentiate minus cos theta, you're going to get sine theta. But the reverse is the case for integration. So if you integrate sine theta, you will get minus cos theta. If you integrate cos theta, you get minus sine theta. If you integrate minus sine theta, you get cos theta. And if you integrate cos theta, you get sine theta. So that is how it goes for integration. So like I said earlier, I said this particular number one example is not for integration by parts. I only included it there for you to have the knowledge of how we solve sine in under integration. So let me go to that example one, which says integrate sine 5x dx. So based on the principle of integration by substitution, change of variable method, so this is actually going to work with it. Yeah, but the difference between there that this one is talking about sine. So now what would I do? I will say let u equals to 5x. So if u equals to 5x, then what would I do? I will find the u over dx. So if I find the u over dx, then that is going to be what? That's going to be 5. So I'll have it as 5. Remember that I've already allowed this 5x to be u. So that will be integral of sine u dx. Now if I have this, what would I do next? I will make dx a separate formula from this. If I do that, my dx will be equals to 1 over 5 du. 1 over 5 du. So with that, I can now replace this dx with 1 over 5 du. So if I do that, then what is it going to be? Integral of sine u dot 1 over 5 du. So now 1 over 5 is a constant. Let me extract it out. That will now be 1 over 5 integral of sine u du. So if I integrate sine u from what I explained here now, if I integrate sine u, that's going to give me minus cos u. So my final answer here is now going to be minus 1 over 5 cos u plus c. Minus 1 over 5 cos u plus c. Now what is u from here? U is what? 5x. So finally, I will have this thing as minus 1 over 5 cos 5x plus c. Cos 5x plus what? Plus c. Cos 5x plus c. Like that. Minus 1 over 5 cos 5x plus c. So this example 2, like I said, is the one that really give meaning to the integration by parts. So we are asked to integrate x cubed ln x dx. So what I'm going to do is that we are going to integrate this x cubed, then leave what? Leave ln x. So later we'll differentiate ln x, then integrate x cubed. So that's what we are going to do. So later we'll not differentiate the both. Just follow the solution that I want to do here. Now let's start by saying ln x, then we integrate x cubed dx. Then you subtract it by what? Integrating, then differentiating, that is d over dx ln x. So we differentiate ln x, then also integrate x cubed, then with what? Dx. Close the bracket, everything dx. Now what does this mean? Look at it very well. This is out, then we are integrating x cubed with respect to towards dx, subtracted from when we integrate everything we have here, everything inside this bracket, inside this big bracket. Let me expand this bracket, everything inside this bracket like this. So we will integrate everything inside that bracket with respect to what dx, but inside the bracket we will differentiate one and integrate one. That is what we are saying here. So continually we have ln x. If you integrate this guy, that will give me x4 over 4, then minus integral of, let me work with everything in that bracket. If I differentiate ln x, that will be 1 over x. Remember, what and opposite. So if I integrate this guy 1 over x, I'll get ln x. If I differentiate ln x, I'll get 1 over x. So then if I integrate x cubed there, I will have x4 over 4. So let me close the bracket, everything dx. Dx because of this integral that is here. So now let me multiply this. This one will be x4 over 4 ln x minus x over 4 ln x minus, now x here 1, x here 3. As you can see, x here 1, then x here 3. So then I have it as integral of 3 over 3x, sorry, x cube over 4, then dx. X cube over 4 dx. Now let me now integrate x cube over 4 dx, which is equals to x4 over 4 ln x minus, if I should integrate this will be, here will be 4 and times 4, that will be x4 over 4 times 4 plus c, and I will have it as x4 over 4 ln x minus x4 all over what, 16 plus c. You can actually leave it like this because there's nothing for you to do there again. So or probably you can just look for the LCM, which is 16, but it's okay for you to leave it like this. So the final answer we have here is x raised power 4 over 4 ln x minus x raised power 4 all over what? All over 16 plus c. So this is how to integrate by parts. We call it integration by parts. So we are done with all the methods I have on this board here. But before I end this video, I have a question for you again for me to explain to you. So now let me write the question on the board. So now look at this question. Now how do we solve it? It's very simple. It's by saying if our f of x is 3x squared plus 1. Actually, this f of x can also be written as y most times. Something like y equals to 3x squared plus 1. Then what are we going to do? So we are going to integrate this 3x squared plus 1. So if you integrate if you integrate 3x squared plus 1, that will be 3x squared plus 1 dx. If you integrate that, then what are you going to get? So you are going to get that will be 3x cubed over what? Over 3 plus x plus c. Remember that these are our y, or either I call it f of x or y. Possibly I love calling it y. You can call it y, call it f of x. It's the same thing in mathematics. So after the integration, which is 3x squared plus x, then you are given, they said whose graph passes through the point 2, 6. In graph we usually have x and y. So this is our x and this is our y. So what are we going to do? We're going to substitute the value for y, which is 6 here, and then the value for x, which is 2 here. So 6 equals to 3 bracket 2 cube all over 3. This 3 can actually cancel this 3 plus what? Plus 2 plus c. So then we have it as 6 equals to, this is 8 plus 2, that is 10. 2 power 3 is 8. So plus 2, that's 10. So 10c. And finally, our c equals to 6 over 10, and that is 3 over 5. So since our c is 3 over 5, then we can now write the equation in full. So whereby the equation is going to be y equals to, so that will be y equals to 3x squared plus 1 plus 3 over 5. That's the value for the c like that. So y equals to 3x squared plus 1 plus 3 over 5. And if you add 1 to that 3 over 5, that will give you, that will be 8 over 5. So our y is now going to be 3x squared plus 8 over 5. So y equals to 3x squared plus 8 over 5. So that is the answer for this kind of question. So give a trial to this. Question is x squared sine x dx. So you're going to use integration by parts to work out this. Let me know your answer under the comment section. Thank you so much for watching this video. Please don't forget to share this video, give us a like thumb, and give us a nice comment. Bye.